horrifying 5% of children are estimated to be psychopaths. These are children who engage in aggressive behaviours, from the more benign like manipulation and lying, to escalating behaviours such as stealing, damaging people's property, or causing fires. They are also famously known for torturing animals, bullying their peers, and generally setting off radars of concern. In some fascinating recent experiments, neuroscientists decided to eavesdrop on these children's brains while the children watched videos of people getting hurt. This video is all about how psychopathy is generated in children's brains, what kinds of psychopathic children there are, and how these children react when they actually see people getting harmed. Psychologically, psychopathy is a disorder which is characterized by callousness, grandiosity, and a lack of empathy or remorse. The diagnosis given to these kinds of children is called conduct disorder, of which there are two age of onsets. The first is called child onset conduct disorder, which occurs prior to the age of 10. The second is adolescent onset conduct disorder, which occurs between the ages of 10 to 18. Typically, the prognosis is more severe if the disorder appears during childhood, as an earlier age of onset is associated with greater escalation of disturbing behaviour, as well as the subsequent development of antisocial personality disorder, which is the adult diagnosis of psychopathy. But whatever their age of onset, the behaviours themselves are still the same. Nonetheless, there is still considerable variation amongst children with this disorder, in terms of their underlying emotions and motivations, leading to the formation of two different subtypes of conduct disorder, which, as we shall see, corresponds to two different psychopathic brain patterns. The first subtype of conduct disorder is the callous unemotional subtype, whereas the second subtype is the reactive aggressive subtype. The callous unemotional subtype can be summarised as the child having limited prosocial emotions. In other words, it is a blunting of emotion and empathy, which in some children can be observed even before the preschool period. Those who show callous unemotional traits tend to have longer lasting psychopathy, show more heritability, and higher levels of aggression, particularly proactive aggression. In other words, the aggression that they show is typically planned, controlled, and purposeful. And they are also less likely to experience depression or anxiety. However, in contrast to the callous unemotional subtype, there is also the second subtype, which is the reactive aggressive subtype. This type engages in aggressive or antisocial behaviour in reaction to perceived threats, provocation, or simply annoyance. This subtype tends to be emotional and impulsive, often experiencing anxiety or some other kind of mood disorder, and often they do express at least some degree of remorse or guilt after engaging in their antisocial acts. So as you can see, whilst the callous unemotional type is motivated by a lack of emotion and exhibits aggressiveness that is calculated, the reactive aggressive type is motivated by hyper-emotion and impulsivity, which will become an important distinction for us when we take a look at their brains. We begin in the year of 1938 at the Emma Pendleton Bradley home in Rhode Island, USA, which was the first ever psychiatric hospital dedicated exclusively to children and adolescents. At that time, a doctor by the name of Herbert Jasper decided to perform EEG experiments on about 70 of the children, all of whom were in the hospital due to their disturbed behaviour. Here, Jasper and his colleagues reported that about half of the delinquent children exhibited epileptoid brainwaves. In other words, their brains exhibited sudden bursts of high amplitude waves, either sporadically or in regular sequences. This kind of activity is characteristic of interseizure activity. In other words, abnormal activity which occurs in epileptic brains when they are not having seizures. This abnormality was then corroborated by other scientists who also reported this strange EEG dysrhythmia in delinquent children. Since that time though, researchers shifted toward use of neuroimaging methods to investigate specific regional abnormalities. But to understand this, we must first take a look at how the brain generates the experience of pain, both when we experience pain ourselves as well as when we see other people experience it. In a neurotypical person's brain, specific regions activate whenever the person experiences pain. This experience of pain is generated by the brain's pain matrix, which includes brain regions like the somatosensory cortex, which encodes sensory information from your body, as well as other regions like the insular and cingulate cortex, which together encode the emotional experience of pain and make you actually experience pain as being unpleasant. What is interesting though is that in neurotypical people, these same regions also activate whenever you view other people in pain. So your brain is literally simulating other people's pain and enabling you to understand what they are experiencing, using these emotional mirror neurons. So much so that in highly empathic people, their somatosensory cortex activation correlates with how empathetic they are as a person. And even in rats, the activation of these emotional mirror neurons causes rats to rescue other rats, who they observe in experiments to be in pain and distress. Furthermore, seeing other people in pain also activates other areas of the brain which are involved in emotional and motivational responses. One important region is the amygdala, which is famous for threat detection, including in detecting other people's pain, as well as in generating aggressive responses. This is because by detecting other people in pain, this is a signal to the brain that you yourself may be in danger as well, conferring a clear advantage in animals evolving empathy. And finally, a second region which activates when viewing others in pain is the periaqueductal grey, or PAG, which generates the fight or flight response. So for neurotypical people, not only are the various components of the pain matrix important in processing their own pain, but they are also important for processing other people's pain, alongside activation from the PAG and amygdala. As a result, seeing another person's suffering is painful for a neurotypical person, because their brains are simulating the other person's painful and unpleasant experience. In other words, in neurological terms, empathy is therefore a bridge which allows someone else's emotional pain to spread to your brain. Which brings us to psychopathic children's brains. As you can probably guess, in psychopathic children, activation in these emotional and motivational areas is abnormal. However, the abnormality differs based upon which kind of conduct disorder that these psychopathic children have. If the child has the callous unemotional type, then this empathy bridge across brains seems to be impaired, meaning that these children's pain matrix is not being activated whenever the children view people being harmed, and so they do not experience empathy for the person in pain, nor is viewing these people in pain experienced by them as being unpleasant. In contrast, if the child has the reactive aggressive subtype, then in fact their brains show overactive activity whenever they see people experience pain, meaning that their brains show stronger simulation of the other person's painful experience. This seemingly paradoxical and surprising result does in fact explain the fact that emotion and distress are associated with increased aggressiveness in these children. These are children who are already experiencing heightened negative emotions, and when their brains then view another person in distress, this heightened emotional mimicry combines with their high emotional disposition, causing the reactive aggressive subtype to become even more aggressive in response. This is because their brains are not only mimicking the distressed person's suffering, but also generating exaggerated amygdala and PAG activity, thereby giving rise to even greater aggression and fight or flight responses. So whilst the callous unemotional type experiences zero or limited empathy, the reactive aggressive type experiences a kind of warped empathy, for which the causes of both subtypes lie predominantly within the pain matrix, either in its underactivation or in its overactivation, alongside amygdala activation in both cases. But in addition to all of this, when a neurotypical person observes a person inflicting pain on another person, social and moral areas of the brain also activate in addition to the emotional and motivational regions, like the frontal lobes, which are the final brain regions to mature in the transition to adulthood. Fortunately, most psychopathic children will lose their psychopathy as they develop into adults, with just 25% of girls and 40% of boys later developing antisocial personality disorder after the age of 18. As you might imagine, those who do sustain their psychopathy into adulthood continue to exhibit altered brainwaves and regional activity, but in slightly different ways compared to when they were children. Firstly, in contrast to the epileptoid brainwave patterns during childhood, in adulthood, psychopathic brains instead show slow wave activity. Neurotypical adult brains are driven predominantly by alpha and beta waves, which are both fast wave oscillations, whereas psychopathic adult brains are driven by delta and theta waves, which are slower waves, and their alpha waves are also slowed right down as well. These slower brainwaves are characteristic of children's brains, as the predominance of these slower waves decreases as neurotypical people progress through puberty. These brainwaves therefore suggest that adult psychopathic brains show decreased brain maturation, which corresponds to their poor behavioural inhibition. Secondly, adult psychopathic brains continue to show the same dysfunctional activity within their emotional and motivational brain areas as they experienced during childhood. However, in adulthood, this situation now becomes even worse. Here, the abnormal activity spreads from these emotional areas to the frontal lobes, which are at the front of your brain and generate your morals, as well as your social emotions, such as shame and guilt. In this way, various parts of the frontal lobes form a so-called moral network, alongside areas of the emotional system that we've already seen. These frontal areas most notably include the orbitofrontal, ventromedial, and dorsolateral prefrontal cortices. The operation of these prefrontal areas corresponds to the type of moralistic views that you have, such as whether you are politically inclined toward the left or right. And they also generate the specific answers that you give to different moral dilemmas or debates. And their activity also determines your views regarding deference to authority, all based on different levels of activity in these different prefrontal areas. Even in neurotypical adults, the functioning of this moral network changes across an adult's lifetime, alongside one's corresponding moralistic views. As such, damaged or underdeveloped frontal lobes are characteristic of psychopathic adults, as it distorts their moralistic views and diminishes their social emotions. Furthermore, the frontal lobes are also critical for inhibiting your emotional system, especially the amygdala, which, as we recall, is overactive in both the callous unemotional and the reactive aggressive child. Here, psychopathic adult brains show not only the same overactive activity in the amygdala, but also show disrupted development of the prefrontal lobes, meaning they are both over-emotional in terms of anger and aggression, and also unrestrained, due to the diminished functioning of the frontal lobes. In order for the frontal lobes to control the emotional system, there is a critical white matter tract which connects both the frontal cortex and the amygdala, which is called the uncinate fasciculus. This critical white matter bundle is one of the final white matter tracks to develop in the brain, and it doesn't finish maturing until well into your 30s. Correspondingly, the uncinate fasciculus is underdeveloped in psychopaths, and so the psychopath's overactive amygdala is not being adequately inhibited by the frontal lobes. Altogether, these findings have led neuroscientists to theorize that psychopathy is in fact a neurodevelopmental disorder, thereby accounting for the typical development of psychopathy during childhood, which then follows the maturational course from childhood through to adulthood, based upon the development of the frontal lobes and uncinate fasciculus. This course of development thereby explains the behavioural trajectory that is typical of psychopaths across their lives. It explains why psychopathy is associated with poorer outcomes if a child is already exhibiting this arrested development at a very young age. And it also explains why psychopathy is at its worst during the teenage years and during early adulthood. And conversely, why their worst behaviour typically decreases by their 40s, once the frontal lobes and uncinate fasciculus have had enough time to finally mature. Furthermore, it also explains why psychopathy is more common in males than in females, because males mature at a slower rate to females, a difference which also renders males to be more susceptible to other neurodevelopmental disorders such as autism or schizophrenia. Lastly, childhood trauma or stress can also cause the amygdala to become hyperactive, thereby accounting for interplay between nature and nurture, and provides an explanation for why the most famous psychopaths have typically had troubled childhoods, which are potentially exacerbated an existing neurodevelopmental disorder. But you can learn more about this in future videos.